develop, if you try somebody else's lesson plan, share comments. This worked really well. I used this warm-up activity. It's taggable, it's still in development. If you have suggestions for it, please tell Josh. And since he's here, please tell Josh. And from that, I'd like just to get started because I want to hear as much activities as possible so that we can all take and steal these and take them home and use them next week. So to get started, please introduce yourself. This is Julia, and then I'm going to get started.
So I can introduce myself. So my name is Julia. I'm mom of 3 kids. I'm an engineer. I was leading the mathematical circle for elementary school kids for 3 years now. I have 2 groups of kids, 8, 9-year-olds and 9, 10-year-olds. But we started with 6-year-old kids, and next year we plan to start another one for 6-year-olds. So thanks to Dave, we're supported by MSRI mini grant. And what I'm going to talk today is something related to the earlier panel when we were discussing whether we need the curriculum or we don't need the curriculum. And so, how did I go back to the pre-class? So, once upon a time, I took my math circle kids to an outing to a rock gym. So when we take the kids to a rock gym, we see that they're capable of many things. They're very motivated. They really want to get to hard and interesting, points. And from time to time, of course, you need to help them, with this rope to get to the handle they cannot reach because their height is not enough. But other than that, this is a very intense workout, and they don't mind it. Correct? We also do not spoon feed them when we do it. We don't start with saying, first you need to climb to this height, and only then to this height, and only then to this height. We provide them the support to climb as high as they want to. So this is, I think, a good place to start when we're thinking about a mathematical circle. So I see the math circle as moving towards an ideal world, and let me tell you what I mean by that. What is not ideal world at the moment? This is what my kids told me, that the only fun time in school is lunch. And what makes school boring? Well, I guess there are many aspects that do, but I was going to concentrate on one. School focuses on what needs to be taught, and those needs are determined by adults who think that they do know what needs to be taught. It is not concentrated on what is interesting to a child. And then we see the problem. We get those easy one-step problems. They are taught to do those very well, but then they're having great difficulties in problem solving later on. So in math circle, we see that young children are motivated by complex problems with multiple solutions, which is quite contrary to the approach that we see in schools pretty often. So as a math circle teacher, you have your freedom of choice. You are able to choose your problems whatever way you like. But what are your criteria for choosing those problems? Skill relevance is not a good one for elementary school kids, and the reason is that you may safely assume that they have no so, but then where do we start? How do we choose those problems? As a math circle teacher, I want to teach them to present interesting problems to the kids. But how do I know which ones are interesting? The ones that are interesting to me may not be interesting to the kids, and vice versa. What are the traits of an interesting problem? So I want the motivation to come from the nature of the problem itself. puzzle together. It's not interesting to play with it anymore. See? They want to explore themselves. Here you see two 5-year-olds who were waiting for their siblings, and they were teaching themselves how to play people. So, I see that young kids love solving problems they have no idea how to solve. And what I found out is that mystery component is essential. The problem should be mysterious in some way. However, teaching from simple to complex frequently takes this mystery out of the picture. This is the problem from current school teaching. And how can we keep this mystery alive? And I don't have any, good recipe for that. I just want you to join me in this research and thinking about it. So, I was wondering, what if we start from suggesting a complex problem first, and then working backwards, trying to help them on the way to find the solution, but starting from an interesting and complex problem, not just a simple, boring one. So, these are some questions that were coming up in the class. Why does water reflect light and grass does not? And that took us in a pretty long and profound discussion about optics. Yes? Or we were talking about weightlessness, and they asked me why the area of why the volume of a sphere, it was eventually. And then we went to an area of a circle for a given perimeter will be more than, say, a rectangle. They didn't know about what pi is. These are small kids. So we decided that square is close enough to a circle. But what we did, we took a rubber band, and you take this rubber band, a loop of a rubber band, you put a square of it, and you say that this is side A. Yes? And then, just by moving your fingers, you immediately see that when you make a rectangle out of it, you have one side gets longer by the same amount as this side gets shorter. And then obviously from here, you see that this is a squared, this is a squared minus L squared. Something is subtracted from a squared. So obviously it is smaller. So it's amazing that they really small kids can prove it and tie it back to their questions about weightlessness and what's going on there. So in my observations tell me that giving hints along the way works much better than straightforward teaching. So this is an ancient problem. I think Alcuin was giving it to Charlemagne. A head of household has 20 servants. He ordered them to be given 20 sacks of grain as follows. Men will receive 3 sacks, women will receive 2 sacks, and the children half of sack. How many women, men, and children are there? There is at least one. So, first they started with individual work and found some partial solutions. Their solutions satisfied the number of sacks, but didn't satisfy the number of people. So I started asking them, are there any limitations on the number of men and women and children? So, working together, they started providing some responses. They said, you cannot have more than 6 men, obviously, yes? So multiply 9 by 6, get more than that. So they noticed that there should be an even number of children. You cannot have more than 8 women, and so on. And thinking about that this way, they were cutting and cutting and cutting the number of people you need there. So, and finally, they figured out that there are several solutions that are fine for 20 sacks, but if you take the invitation of 20 people, there is only one solution, which is 14 kids, 5 women, and 1. So, it is often assumed that solving complex problems always requires a lot of knowledge. However, we need to distinguish between the knowledge needed to understand the problem versus the knowledge needed to solve the problem. Two very different things. Many complex problems can be stated in such simple terms that can be grasped easily even by a very young child. And these problems can create significant interest in a child, leading him to explore on her own. So, this is a problem that many adults can be confused with. 10 gnomes are caught by a dragon. So the dragon lines the gnomes so they can see the heads of the gnomes in front of them. So the dragon has a large bag full of black and white heads. The dragon randomly reaches into his bag and places a head on each of the gnomes, whether a black one or a white one. So then the dragon asks each gnome, starting from here, what is the color of your head? So if the gnome answers correctly, he is lucky. If not, well, he is eaten up by a dragon. So the question is, the gnomes can communicate prior to that. They can develop a strategy prior to that. So the question is, what is the maximum number of gnomes that you can save from this ferocious dragon? So, this is a nice question to discuss after you discuss parity. Because most of the people start thinking about probability. I'm going 50-50 and so on. But actually, after you taught parity, it's easier to guess that you can just say, I'm going to communicate the number of black heads, whether it's even or odd. So, another type of problem that creates a lot of interest are open-ended problems. They are always welcomed by the kids because it allows their creativity to flow. In one problem, I asked them to find a way to add all numbers from 1 to 999, and I didn't tell them the way it goes. So, this is a solution from a 9-year-old. He said, everybody can add from 1 to 9. So he says, let's the first sum be the sum from 1 to 9. The second one will be 10 times that. So we know what is 10 plus 20 plus 30 and so on. And then add them together. Calculate how many times 1 plus 9 goes into that. And so on. And then do this by analogy. So it is not the Gauss solution, but it's still a pretty workable solution. Okay. So very interesting how their heads work. So they love the exploratory problems. I asked them to take a compass and a ruler and try to construct a triangle with the sides 1, 3, and 7. That took them a long time. They thought that given a compass and a ruler, they can do anything. So, and after that, it very nicely led us into discussion of triangular inequality and so on. So, but we started with something that created their interest, that kept their interest for a really long time. So
Julia, I'm going to have to wrap you up.
I have just a few more.
Perfect, okay.
Okay, so a very interesting one. All of them agreed that the straight line is shorter than the curved line between 2 points. None of them, though, were able to see that D plus C is longer than E. Because them to just slow down and concentrate on what they're seeing. And same as here, like that was supposed to be a thing. Showing that the area doesn't change if you turn it around. So they love those proofs and demonstrations with outputs. So they love problems with unexpected solutions. I don't know if you know this one. It's a good one. So sometimes adults attribute problem complexity to the lack of knowledge rather than their own suppressed creative ability. There are many puzzles that seem difficult to an adult but are easily solved by youngsters. So tell me, what is the rule for separating these sets? 1, 4, 7, and the rest. They gave me an answer like
number of elements?
Straight versus curved.
Yes, straight versus curved. Where was the Declaration of Independence signed? It's not mathematics.
At the bottom.
At the bottom. What is the difference between here and there? Okay, so I have some discussion suggestions. How do you distinguish between an interesting and a boring problem for yourself? How do we keep the mystery alive? And it would be great to have a database for interesting problems with kind of maybe ratings from the students that says like, I love this problem because, and I wonder what that because would be and whether we will be able to find something common and all those explanations. And we'll be able to create more interesting problems for the kids that motivate the kids by just the nature of the problem. So that's it.
The way that we're set up today, we went for youngest, and then we're going to slowly keep getting older in terms of our problems as we're going. So Anna's going to go next.
Oh, I'm sorry. Just close the thing.
Okay, so let me introduce myself. My name is Anna Duranga. I teach at Prime Factor Math Circles and Math Circles of Northwest Academy of Sciences, Seattle. We started our first math circle in 2002, and we are a group of enthusiasts who enjoy spending their free time teaching extracurricular mathematics to children. So currently, I teach 4 math circles, grade 2, 3, 4, 5, 6, 7, and 10, 11. And last year when I presented here for good topics for middle school circles, I claimed that I think the best age to start my circle education is grade 5, 6. Now that I teach grade 4, 5 and grade 2, 3, I don't claim this anymore. Really, grade 4, 5 and grade 2, 3 are great ages to start my circle education. Okay, the only question is how to teach this grade, how to teach that grade. So I'm going to concentrate on grade 4, 5 circle. So if you have a mix of students of grade 4, 5s, definitely you have a set of constraints. And these are mostly will be defined by your 4th graders. And I don't put them in writing. I don't want my 4th grade student to be offended if they ever find a trace of this on the internet. But what do you have? First, you have very little mathematical apparatus, like no proficiency with algebra, no geometric sense, very little number sense. You have kind of abstraction thinking gap, like 5th graders somehow much easier to teach abstract ideas than 4th graders have. And you have a few other problems with 4th graders, like difficulty to manipulate with objects, with their hands, whatever. So we have a set of constraints and restrictions. Now, we should try to figure out what our goals are. Again, if you teach a circle of higher grade students, your goals could be more ambitious. You could shoot for teaching them elements of some math theory, like this or that way of thinking. With younger students, your goals should be a little bit different. Just teach them to reason, to think logically, to be creative, to learn to be flexible and apply different approaches to a problem. Basically, teach them to understand math. So, now you have constraints, you have your function, you want to maximize. It's a kind of optimization problem. And if you have a problem, it's always possible to find a solution. So, solution, now let's just look for the topics that satisfy these constraints and kind of maximize the function of your goals. And the surprising thing that there are a lot of topics like this. First, teaching principles. They're important for any age, but especially for the younger students. First, problems should be entertaining. Like, have a storyline, witches, wizards, dragons, Harry Potter, anything. Makes it much easier. Second, keep the difficulty balance in problems that you assign to your children. You have mix of grades, you have mix of abilities, you have mix of knowledge and preparation for the students in the room. Everybody should leave your room with a feeling of success. It means half of your problem should be accessible to everybody. But part of your problems should be challenging, last two, should be challenging for your top students. Then everybody is happy, everybody feels he or she achieved something. Then mix problems from different topics. Like if you spend your whole hour and a half talking about problems all at the same time, your kids get bored. Just mix up something else. You can even teach elements of math theory to students of this age. Again, if you reasonably set your goals, if you keep them within bounds. Okay. So, finally now, topics. So first topic I want to start from is constructive problems. It's a great topic for students of this age. So these are problems where students are actually supposed to figure out how to do something. Cut, make, get to some result. The students love them because it's kind of hands-on thing, so they are able to solve them. Teachers love these problems because first, students love them. Second, these problems are actually a great opportunity for a teacher to illustrate the value of intellectual reasoning. Let's do a few examples. Okay, so cut the big shape into 4 equal parts. Equal means of the same shape, not only the same area. Each part should contain exactly 1 smiley face. Okay, so there are several approaches to the problem. You can just try cutting, or you can explain that first think about how many little squares are supposed to be in each part. Since we have 16, then 4 per square. Then, how many ways can you combine these 4 little squares? And which of these configurations definitely not going to work out as solutions? Eliminate possibilities. You are done like, then you have this like intelligent trial and error strategies that's much easier, bring you to basically deliver the success in the problem. Next problem of similar kind. Cut the big shape into 4 equal parts. And this one is more difficult because these are not squares. There's a strategy of figuring out how many triangles are supposed to be in each part really pays off because it really limits your exploration space. Another constructive program adds several mathematical operations and parentheses to following lines to turn them inequalities. Qualities. Okay, what's good about this problem? First, students get some exercise in manipulation with numbers. But also, it's a great educational problem. Why? Because you ask your students, suppose you already have solutions for these, how could you generate solutions for these problems if you already solved them this and that? Or maybe if you've solved this one, how would you generate a solution for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? So sooner or later, somebody in your room would notice it. If you add parentheses to the result that's already equal to 5, and then plus, sorry, what do we do? How do we get 1? Plus, no, we multiply, yeah. Okay.
Plus 6 plus 7.
You can figure it out.
We build on the 1, 2, 3,
Yeah.
4.
So basically, again, a solution to a more difficult problem that builds up on a solution to an easier one. So great for kids, great for you, great for education. Okay, then there is this whole sequence of problems about balance scale pens and fake coins problems. So these are problems either of the type like you compare certain quantities on the pens and try to figure out some relationships about these quantities, or there is this whole sequence of problems about fake and real coins, and like you have not this many tries, you're supposed to figure out which coins are fake, which coins are real. Really, really nice problems, and a lot of them out there. Word problems. Okay, what's about word problems? Again, most of the students of this age are kind of scared of them, especially if they are not one-step problems but require something new. And again, your goal is not to teach them to write equations. It's not your goal for this age. Your goal is to teach them to analyze the problem, to build a model, and to find an easy way to solve it. So how? Let's check it on an example. So that's a problem. When a little rhino, little elephant, and a little hippo were asked about their weight, they replied as follows. Rhino, I weigh 100 kilograms. Hippo, my weight is that of the rhino plus half of the elephant's weight. Elephant, I weigh as much as the hippo and the rhino together. So I had a number crunchers in my class who wrote a system of equations with 3 variables. But it's not what required. What required is just to make a really nice drawing that would illustrate this picture. So, rhino, okay, 100 kilograms. Hippo, okay, so this 100 kilograms plus half of the elephant weight. We don't know how much is it, but it's half of it. Then, elephant, hippo and rhino. So, 2 of these and 1 of those, and together this and that actually add up to this whole red color block that's weight of the elephant. So that's 2 halves. And after you illustrated a problem like this, it's obvious that half of the elephant's weight is 2 of these 100 kilogram blocks. It's 200. So it's teaching about the ideas behind problems of this kind. Next example. 300 rows had a stone eating contest. So one row ate 10 more stones than the second one, and the second one ate 15 less stones than the third one. Together, they consumed 88 stones. How many stones did each row eat? Again, it's a word problem that can be solved by writing down an equation. But you don't need it. There is a much easier approach and much easier technique that you can teach to your students. Okay, so who was less hungry? I think Bob. So Bob, Jim, above. Then gym, these stones and 10 more. Siegfried, the same amount of stones and 15 more. So together this, and this adds up to 88. So suppose we temporarily chop down these extra stones that were consumed by trolls who were hungry. So if we remove these stones, then each troll would eat a same amount of stones, and it would be 88 minus this minus that, whatever number it is. So now we have sum of 3 equal quantities that adds up to some wave number. So you get this quantity, then you deduce number of stones consumed by Jim and Siegfried as well. Again, apparently difficult problem that's quite accessible for a fourth grader if the approach is right. Okay, next topic. A priest problem. Aladdin enters a dark cave. He knows that the treasure chest in this cave contains 17 real and 13 fake diamonds. What is the least number of stones he should take without looking to leave the cave with 2 real diamonds? Okay, problem is good because it's intriguing. Then it's actually easy for kids to produce an answer. But your goal is not to teach them to generate an answer, but to justify it. And it's very, very, very nice topic to teach them some mathematical reasoning. They should justify necessity and sufficiency. They should justify that if he takes less stones than it could happen, that he end up with less than 2 real diamonds. And they should justify that if he takes that quantity, he always end up with 2 diamonds. So, like, nice illustration of this type of reasoning, and kids really love it. Graph theory, another really good topic. Again, the question is just setting boundaries. How far would you go? Definitely, you should not teach them the theorem about even number of odd vertices in a graph. Overkill. But all the problems about tracing a graph are just great. And it is possible to teach them that if a graph has 0 or 2 odd vertices, then it could be traceable. And they really love it. Like, if you formulate a problem like, and start to explore a problem like, why you can trace this thing and then why you cannot trace that thing. It's a really exciting problem and quite educational. Okay, that's it.
Hi, I'm Pat Jones. I'm retired from Louisiana Lafayette, and we run a circle for middle school teachers. But we ended up with a combination. High school teachers asked if they could come, and we have a wonderful situation where we have 6 faculty people who come regularly, and they are all the people who teach the pre-service courses for the elementary and high school teachers. So we have a wonderful mix. They also people who are up to their necks in summer projects and all kinds of professional development stuff. So they're in on all aspects of professional development, and then sitting there at the table with the middle school and high school teachers. So we think it's a wonderful mix. The problems, what I did with the problems is a little different than what we've done. I brought 5 problems, and we're not going to solve them, or even talk about how we solve them. I'd like to give you a copy, and I want to talk about the 5 problems in relation to each other, if we could do that. There would be 2 of these problems. Let me say this about the way the circle runs most of the time. These are people now who are coming for there's no motivation involved. They're coming because they love to get together and solve math problems. And so they're not necessarily wanting something to bring back to their students. They just want to come and do math. And so problems that we do are not necessarily the same thing you would do with a student circle or a circle where you would worry that these people needed to learn some math. We talked this morning about connecting to the curriculum. I worked with groups where I really felt the problems needed to teach them some of the math in the curriculum because they just weren't prepared. But that's not the case with this circle. So I just want you to understand who will be getting these problems. They've done the first 2 already. And I want to talk about why these, and after they've done all of them, what are we going to come together and hopefully talk about, and then where are we going to go from here with these? And they start off with 2 things that are really, the middle school teachers in the group are going to do trial and error with a lot of thought put in. When they get to, in each of them, the first one's just, writing this as a sum of 2-unit fractions. One's a prime and one's not. Okay? Then we ask them, guarantee us that we can always get at least 1 pair. For any whole number, we can get 1 pair of unit fractions. Then in the next one, it appears that things change to geometry, but actually that wasn't the point, that things appeared to change to geometry. What they come out with is something that looks different from unit fractions, but is the same thing. All right, then we get to the next one, and it's a typical high school work problem. Joe did it in 5 days, and Harry did it, and we hope those disappear. But they haven't disappeared. The problem is, all of us sitting here wish they would, or at least they would change what they sound like. But they're still there. So anybody, if you say a typical work problem to a group of teachers, everybody knows what we're talking about here. Well, this one, the first part of it, the 2 pumps pump it constant but different rates. And you have the first situation where you know how long it takes one pump to empty the pool alone. And instead of knowing how long it takes for the second pump to empty the pool, you know the time it would take if both pools were operating. The arithmetic's the same, basically. And it's not a problem, it's just they find the answer. And it turns out to be a decimal. And so the next question is, now I'm the teacher. I'm the 9th grade algebra teacher. And I came across this problem, and the students worked it. And now I've decided to give them one where everything's going to be whole numbers. Because I want to concentrate on what's going on in this thing, and what's the real important thinking part, as opposed to getting bogged down in numbers, decimals, or fractions. I just want it to be as clear as possible. So I want to make up a work problem where 6 if both pumps were pumping. But I want both of the individual pumps to have a rate, which is a unit fraction. So it's a totally different thing, and we're coming back to unit fractions. We started off with something that appears to be a plain old work problem. But underneath, that's not what it was intended to be. So, okay. So now, hopefully, they're going to connect that to the first one and build on it, and we'll see where they go. These, you know, we haven't discussed any of this yet. They've just been working on the problems. Then maybe the next time we meet, number 4 is going to appear in the problem set. And, of course, number 4 doesn't seem on the surface, if they haven't already seen it. It's the famous, the old traditional ladder problem you recognize. But not all middle school and high school teachers have done the ladder problem. Nor do they realize that it's the solution to the ladder problem is also the solution to the work problem with the same whole numbers. Most of them don't know that, and that's one of the things we would like them to discover and enjoy discovering, because these are people who love to see, oh wow, that's pretty neat. Those two totally different ideas are exactly the same thing going on underneath. Then the last one here, we ask them to take the equivalent statement of the sum of the unit fractions, which is looking more like divisibility now than it looks like unit fractions. It's the product divided by the sum. We eventually want to get to what about any n? But we're starting off with, suppose the product divided by the sum is a prime. Can we at least prove for that how many different ways, how many different pairs A and B do we have? So all of this is the same thing at different levels, with a few nice things thrown in for the teachers. Middle school teachers typically are not going to immediately see the similar triangles in the ladder problem, which has become the tower problem in here. They don't see those similar triangles right away, and they don't see that the answer is going to come from either using unit fractions, what they know about unit fractions, or a product divided by a sum of whole numbers. So all of these things are going to be, hopefully, a part of the final, when we get together to look at the whole set of problems and how they went about getting their answers, and how all of this is basically the same thing. What do they see here? And then progress to number 5 when it's not a prime. The next one would be, suppose the number is P times Q, where P and Q are different. And we see how far we can go. Frankly, with our circle, I don't know how far we'll get to go. Where, you know, once we've done all of these, and then we get to PQ, we'll see what we can do next. But it's just a little different, and it's a different level of people than we've been talking about in general. We've spent a lot of time with the younger students, so I thought I'd throw in something with people who knew some math. But not a lot, but some. Thank you.
Listen, if we can do questions at the end, that would be really great. Is there an immediate burning question that someone can't wait? Okay. So if that's okay, if you wanted to introduce yourself.
maybe I can sit here, or you want me to stand there? Maybe you stand there, so I'm visible to everybody. So I am Răzvan Jölca, and I'm an associate professor at Texas Tech University. But mostly I'm here because I'm involved in math competitions. So I'm basically every summer I coach the US IMO team, and I do some other countries every once in a while. So I did India, I did Brazil this year, probably Mexico next year. And I also work with Tito Andrescu. Both with his awesome math, and I give lectures in his math circle. Now in terms of math circles, right at this moment I do not organize one, but I have organized in the past, and I will talk about it. I will mainly insist on the fact that I'm speaking more as a product of math circles, so I'm like the guinea pig of this experiment, so you can see how somebody will look like 30 years after. And I want to talk a little bit about my experience of how things evolved. So in some sense, I'm still stuck in my high school years, so I like this story about these math activities so much that I never grew up, and I somehow still live in that universe. So I come from Romania originally, and in Romania, the fact is that all math activities were very well linked. So the high school curriculum, what was done in math circles, math competitions, and math journals for high school students were all connected in the sense that you were very well motivated to be good in all of them if you wanted, you know, to succeed in your later studies, like to pass the high school entrance exam, the college entrance exam, and so on. Now, I want to talk about 3 math circles that I attended myself in my development. So the first one was in grade 7th and 8th, when was the time when I discovered Euclidean geometry. So it was the time when we were exposed to proofs, and my math teacher felt like going beyond the textbook and teach us more stuff at such a math circle. So I really want to insist about this somewhat overlooked aspect of mathematical education. I mean, Euclid's book is definitely the most important non-religious book ever. And so I think that we should expose children to it, and quite early. I know that I was quite excited about these proofs. I mean, I never felt motivated to prove things about numbers, but when I saw geometric objects, somehow I wanted to know if something was true or not about those. And I think Euclidean geometry is quite friendly if you start it the right way, so I want to point out towards it. Later, when I got in high school, I started working hard for math competitions, and I started working with Tito Andrescu, whom you've seen 2 days ago. So now you get to see the teacher and the student in one event. What I very much liked at that level was that we switched to problems that were complex and had very surprising solutions. And later, in my last high school years, so Tito Andrescu was running his sessions like on a weekly basis, and we would meet. He would give us a number of problems, and then we would solve them and discuss them at the blackboard. But later, towards the end of my high school years, we students actually wanted to solve just problems ourselves. So we would gather every Sunday, and we would sit down and think about 3 or 4 problems for about 5 or 6 hours. And at the end, we would probably get 1 or 2, and then it was Tito and somebody else, Georg Eckstein, so they would make us feel like fools, showing us 2-line solutions to all of them. Now, what I want to say is a little bit about the psychology of the kid that I was. So what I liked very much was to be challenged, to be forced to be creative, and also to be competitive. So in this sense, I'm saying that probably it's not a bad idea to link these activities to the math competitions, because kids are competitive. That's why everybody practices sports. They want, to show off. So math competitions are a way of showing off that they are doing well in mathematics. And in fact, they are also a way of proving concretely that they know math, so it's something that helps them get into good universities later on. And I want to insist also, so there's always this question about motivation. I mean, parents are really motivated if they feel that their students will be able to go into the big schools. So I think that this factor should be remembered. Now, how do I teach nowadays a math circle lesson? So usually what I do, I think like, what would a student need mostly? You see, the purpose of these training programs is to somehow deliver the largest amount of knowledge in mathematics in the shortest amount of time. So we are trying to be as efficient as possible. So whenever I teach a lesson, I'm trying to think like about one fundamental thing in mathematics, like the invariance principle. It's something that keeps going in mathematics. In basically the hardest parts of mathematics nowadays, invariants are the core. Algebraic geometry, number theory. So I'm trying to think about one fundamental principle in mathematics, and then I try to look for problems. And I wanted to come here. So at this point, so I want to insist that at this moment we are at the golden age of books for this level. There have never before been so many publications that are appropriate for high school problems. So mostly, I mean, the American experience, you can find it throughout all the publishers, but I would say mostly the MAA try to capitalize on this problem-solving stuff with their books. The Russian experience somehow got into the AMS series, so they published a number of very good Russian books. The Romanian experience you can find mostly in Springer and Birkhäuser. So whenever I prepare something, I just browse through a lot of material and try to find problems that are attractive and challenging. The second thing that I'm trying to do is I'm trying to compensate for a certain imbalance. You see, in the US, we attract people to mathematics mostly through combinatorics and number theory, and you can see that at the International Math Olympiad. So, like when we go there, we keep our fingers crossed that they will select hard combinatorics problems, because then we are up. So, for example, I went with a team in Spain as a deputy leader, and then the first day, the second problem was algebra. Basically, the big thing was quadratic equation. That's where we lost most of the points. Hadn't it been for a quadratic equation, we would have won that year. Instead, next day, we had very hard algebra, very hard geometry, so next day we had the highest score because of that combination. I said the very hard combinatorics and very hard geometry, so immediately we jumped. So I'm trying to compensate in my lectures, looking for the least popular subjects and trying to make them more popular. And just to illustrate, I want to talk a little bit about calculus. I mean, everybody showed a few examples of problems. So I'll show you just two examples of calculus problems. This is the subject that everybody hates very much. So, and of course, we avoid giving lectures on calculus in math circles and math clubs. And so for that reason, I actually gave a talk about a year ago at the math club in Yale about just calculus. So here's one example. So you notice that 2 to the 0 plus 5 to the 0 is And you notice that the same thing is true for 1. But are there other numbers for which this works? So what about this equation? So this equation, in a different form actually, I had at a math competition when I was in high school, and I got so excited that I remembered it ever since. So how does calculus show up? Well, you rewrite it like this. Even better, you rewrite it like this. And now you see that if you look at the function f of t equals t to the x, then here you have those expressions that show up in the mean value theorem. So you will have f prime of some t1 is f prime of some t2, where t1 is in t3 and t2 is in 4, 5. And of course, that cannot happen because f prime is, I guess, either increasing or decreasing unless you're in one of these two situations where it's constant. So that's one example. And the second example has the flavor of number theory. It actually starts with those numbers that taxi license plate that was noticed, I think, by Hardy and by Ramanujan. Certainly, Ramanujan was there. I think the other person was Hardy, saying like, "Oh, what a boring number, 1729," because it doesn't have any important mathematical properties. But in fact, Ramanujan pointed out that no, it's the smallest. What was it? The smallest or something that was the sum of 2 cubes, yeah. So, yeah, so you can have equality of the sum of 2 cubes, and you can have, two different ways of representing the number of the sum of 2 squares. But can this ever happen with the same numbers here? So can you have u cubed plus v cubed equal, x cubed plus y cubed, and u squared plus v squared, well, x squared plus y squared simultaneously. And the fact is that we can play basically the same game over there. We could do u cubed minus x cubed over u squared minus x squared equal y cubed minus v cubed over y squared minus v squared by algebra, right? So they are equal, because this is equal to that and that's equal to that. And then, of course, we can go to whatever, a, b, c, d, and do something like a to 3 halves minus b to 3 halves over a minus b equals c to 3 halves minus d to 3 halves over c minus d. And we're back to where we were. Another mean value theorem. Basically, here you take the function f of t equal t to 3 halves. Well, things are slightly more complicated. You have to be sure that the intervals a, b, and c, d, or whatever b, a, and d, c don't overlap, but you can arrange that by moving the right guy from here to here. So you move, if this one's bigger, you move the bigger guy from here, and then this one will be the smallest. So you'll have that the intervals dA and dC be non-overlapping. And then again, the mean value theorem tells you that this one will be some f prime of t1 another example. So now it just crossed me through, it just crossed my head. So I said 2, but this one. And this came out of the cheating at a math competition, so I'm not telling the person, but that person almost, got the point. So the question was to prove some inequality, and then this person said, well, we'll use this obvious fact. Is if ABC is equal to 1, then, and the A, B, and C are positive, then A cubed plus B cubed plus C cubed is greater or equal than A squared plus B squared plus C squared. So then there was somebody spotted this and said, oh, whoa, wait a second, is this obvious or not? And so we scratched our heads, and after a while we realized that, well, in some sense it's obvious, but it's not supposed to be. It is obvious once you say the right things. So you take the function f of x equals a to the x plus b to the x plus c to the x. This thing about playing with the variables and the constants, this is something that I learned from Tito Andrescu, and I very much liked, his very tricky problems. So, if I ever have to solve some math competition, it's always this stuff that I cannot solve. So you look at f prime of x. You're trying to show that it's increasing, but unfortunately f prime is a to the x ln a plus b to the x ln b plus c to the x ln c. And these folks are of different signs because the product is 1. So we are stuck. Well, not really, because what we notice is that f prime of 0 is ln of abc, and that's 0. And we notice that f double prime of x is a to the x ln a squared plus b to the x ln b squared plus c to the x ln c squared. And now this one is now negative, and then, well, it's actually positive, it's the term of 0. And now you know that f prime is increasing. So if it starts at 0, at 2 and 3, then between 0 and infinity it will be positive. And then you know that equality holds, the function is increasing. Yeah. So I didn't really come prepared to show you problems, but it crossed my mind that maybe it's a good idea when I state a principle to actually illustrate it with something. So as I said, my point here was that I'm trying to cover other topics than the ones that are so widely illustrated in math circles, and I'm even going for the least popular ones, because then I'm certain that the kids haven't seen anything, because because previous speakers probably avoided that. Okay, so I think I'll stop here.
So we've managed to go from trolls all the way up to calculus. I think the consistent thing that we've seen throughout all of this, though, is that knowing the audience that you're working with and knowing your strengths and what you're passionate about sharing with your students. Is lunch here yet?
Apparently not.
Who drove Sam?
So then we have time for questions. So does anyone have any questions for the panel? Or any comments to support?
I have a comment, I guess. So, an observation, first of all. It seems like one of the most important things in all, I love coming here and getting all these ideas, and I'm certainly leaving with tons of ideas, but it seems like teaching what you personally love seems like sort of the meta theme here. And that just seems like, I don't know, when we're talking about like helping teachers or anything like that, it seems like giving teachers permission to teach what they love and potentially, squeak a little extra space away from the curriculum if they can get more of their own personal love into it. It just seems like that's what makes these things work, is that everyone is doing what they love. So that's one observation. The second is a comment. At Math for Love, where we are teaching different groups, we often have, rather than try to come up with the right problems for the students, we do that also, we often try to get the students to be coming up with the problems as well. And somehow that's a very powerful act and a very powerful part of mathematics. And we get this beautiful thing happening eventually where we almost have self-running circles where the students come in with a question each day, and when you have 15 students come in and each one has a question, then suddenly you don't have to be telling them to do anything. They just say, I want to work on that person's question, and you can have the whole range from, you know exactly where they are and exactly what they're working on, and you have eventually these beautiful questions, and the skill of posing questions develops. So I just want to make a plug for that idea also.
I'd like to follow up on Julia's idea for a database of good problems. I mean, there are obviously collections of problems out there, and have been even before the internet, believe it or not. But the question is, does anyone know of a database of problems with rich metadata beyond this is a good problem plus good problem, or the level?
So DNAMC is trying to get this off the ground. We have a problem database and a Math Circle lesson plan database. Maybe here in lunch when this ends, I can turn it on the computer and show what it is, and hopefully we can get people to start adding to it, and we can add comments. It's on. Yeah, we can turn on the computer and do it.
Can I ask you while you're doing that?
Please.
My question is related to that. I know where the problems are. I got lots and lots of problems. The hard thing is organizing the problems.
Rich metadata.
So how do you make a searchable database? By what criteria do you search? What questions do you ask about the problems? That's a harder question. How do you organize this material?
Well, sounds like it may need some kind of roadmap. I hate to go back to the word sequencing and scope that usually used in standardized curriculum, but maybe those problems should have a roadmap and some kind of sequencing so that this concept is actually can be mapped already into the
And the question is, what does that roadmap look like? Sometimes it's not directly by the skills or the problems. Sometimes it's by the problem-solving method used. Sometimes it's by the sort of the way the problem captures one. It's not a simple question. It's not as easy as when you do it with curriculum. That's what I'm saying.
Right. I understand that. There could be multiple layers. One is at the level, right? It's the same concept can be taught at the different levels, and you control where you stop, right? And then there is another type of question. Is that the math contest or the visual or the conversational storyboarding?
One idea I was working on was sort of a wiki type thing where we'd have problems in some. All right, you have so let's say it's YouTube. You have David Hankin doing one problem, and then somebody else doing another problem. So we have 20 problems, and then people create links between the problems. This was nice. It reminded me of that for this reason and so on. That's one way to look at it, because that's what you create in your head when you do this.
What Mark is saying, the order of magnitude, the order of difficulty of tagging and managing such a database is many times harder than just collecting problems. It's maybe thousands of times at least harder.
So I think, so I know Richard in the past has worked, or Richard Rustick of problem solving has actually worked on this specific problem. to the point where he's actually added manually tagged problems from both the AMC and a ton of other math competitions. So I think he would actually be the best person to start talking about this type of project, as he not only had people manually tagging it. I remember he hired free Stanford artificial intelligence
Is this the same
PhDs.
project?
That's through artofproblemsolving.com. Yes.
Okay.
Yeah,
He
so
has
had
a
few-
free interface where called Alchemist that anybody can just create an account and select a topic and go through the problems related to those topics. Is that what you're talking about?
Yeah, so he had actually people tagging it originally, and then he had free AI PhD students code up an algorithm that will automatically classify problems. So he has something really pretty already in.
And he also has a huge audience that already knows where his site is.
Exactly, and the students already tag them for free practically for him.
Well, I guess my comment to this would be that we've tried to create this as much as possible on the mathcircles.org website. What we've developed, if you go to our front page, math problem collection. I'm guessing where you've spent a lot of your time is finding a math circle near you. You've added your program, you've added. Come back, spend a little bit more time on our site and spend some time in this problem collection. What we have is 3 different ways of looking at problems. We have problem lists and problem sets. What we mean by that, what the distinction is that a problem list is just every single one of these little problems. So looking at Pat's problems, each one of the 5 problems would have its own problem listing. And if you click on one of these, they're tagged as it's either, it's a moderate, it's a, in terms of level of difficulty. What we decided to look at was prerequisites in terms of the knowledge students should have, that they're going to need to know some algebra, maybe they need to know calculus, and then we've also started to look at tags like pedagogy, like this is going to be a great warm-up problem, or this will be a group movement problem, or things like that, and then levels in terms of topics and polynomials and algebra. You can then take and pull these problems together and pull them together as problem sets. So each one of the 5 problems would be listed separately in our problem list, but then they can be pulled together as a problem set. And what is nice about this is that we will, the website is set up to then make a printable set so that you can print this off and bring it directly into your math circle for use that day. We're also trying to get it set up so, because we know that a lot of our groups are working with teacher circles, so that it would be printable both in terms of here is the student sort of worksheet, and then here's a solution set to go with that. And that wouldn't print up directly, like those would be 2 different PDFs. And then lastly, we have Math Circle lesson plans, and these are complete lesson plans. And this is all searchable, so parity comes up, and yeah, and so it's all searchable. It's all stuff. So a lot of the contributions you'll see have Ockley or Zucker. This isn't nearly as useful as if it's just the 3 of us or a brain drain. Then it's much better if we have a whole entire group of people here that can contribute and make it bigger and bigger and bigger. And so what's even better is that we're trying to grow this, and we've developed a YouTube website so that as we have videos, these lessons are even better if we can take and actually see you doing those lessons happening. And so there's the National Math Circles website. We actually started one for San Francisco where we put our San Francisco pictures up, and then we've linked that to lesson plans that we've done as well. And so you can either use ours or develop your own. We'll talk about the liability of aspects of that later on, but so stay for me. And but I think that it's developed. If it's not what you need, help us make it what you need. If this isn't, like, let's not try to make another site. Let's make this into something that actually is what you need for this community. Because we've spent a lot of time talking with all of you here, and we've done, we've gotten it as far as we have, but we need to know what else do we need. And I didn't want to cut you off.
I really want to know, Bill, when you're at that first site that you showed us, does it link to that video?
Yes.
Okay.
So that was,
what I wanted to
so I can,
do.
Because that would be great. Like if you see
Yeah.
something that looks good, but you want to see, well, how does this actually work?
I
It would
would
be nice to go from the text directly to the video.
And that's, it all is linked in there.
I
Yes.
want to actually go through just a little bit here. First of all the Circle on the Road, the sample sessions we've been videotaping, the workshop we've been videotaping here. We did this also for last year in 2010, and then we've got this searchable database of problems where you can search it with tags. If we don't have enough metadata, if you want us to add metadata, let us know. I didn't turn comments on this one. I've got comments, I'll turn comments on this one. But we have the discussion where we have the wiki, where people can add comments. We'll add evaluation. We'll have an evaluation session. And so we can add comments about different things that we can do. And so in the middle of these things, I don't want to, so I didn't turn on a section on this, but I can do that. But you'll notice that it'll have the lesson plans, the LaTeX, and put handouts here, and it'll have links to the YouTube site. And our YouTube site is not just the run-of-the-mill 10-minute YouTube lectures. We can put a 90-minute lecture up because we're a nonprofit. And so if you let me know, we can get a full map. So this is the full parody session from yesterday, linked here with the lesson plans and description.
But you already have it up yesterday?
I just have playing with parody just to show that it could be done. It will probably take me 2 months to get chemistry in this. This just was created on this Thursday, and so that's why Circle on the Road from 2010 is not up.
What I would like to suggest, even more engaging than just having a link, if you can embed, so, people see there's a video and they just click the little, triangle and go, rather than just a link.
And so what we've done last is we did social networking is what we really focused on, and so we were trying to have more interactions. That's definitely what we'll look at for the next grant cycle, but previously what we've really been focused on is more trying to create social networking aspects to the site.
I have a question. Do you think collecting problems works in the sense that you can sort of reach a critical mass of problems and so that you can go through the problems and there will always be something that seems novel and interesting? Because I find anyone who's written a competition probably knows that writing problems is really, really hard. And there are lots of famous problems that are great problems, but I know I can't put them on the competition because about half the kids will have seen them. So it also has the effect that lots of people have heard of something and once they've heard of it, even if they don't understand it, they think they do and aren't interested in learning about it.
So I think it depends on what the goal is. I know that for me, especially in terms of training new instructors, to have a resource of really well thought out problems and a chance to try it for themselves along with comments about what it was like to use it. I don't know that this is really ready for sort of competition level, like completely new novel problems in that sense, but other comments?
I have a question about this. Is this a wiki or is it something?
It is a wiki, so that's what I wanted to show you.
But you
that
have to be logged in in order to do it.
you have to be logged in order to do it, and you will have 2 levels. Probably you'll have to be registered as a teacher to see the lesson plans, but a student can see the problems but not the solutions. And most of these were supposed to have comment sections underneath. Let me go back. I didn't turn. Oh, I see. I understand why I couldn't.
The other thing is that your students would have access. For younger students, they do need to do a sign waiver in order to have access. In terms as a user, the logged in user that doesn't have access. Josh, did you have anything to add?
I'm just answering the question of embedding the videos instead of putting the link. I'm fixing that right now.
What about for other issues other than problem collecting? Like I have several things that I personally would want more info about. For example, there's a whole bunch of things like what are good times to meet. I know that's discussed in Circle in a Box, but I would like to hear lots more experience about that. What are good times, recruitment, mixing kids, just like lots and lots of different issues like that. And I know there's a couple of email lists, but to get, there's not that many people on the email list.
So, so one comment, so just going back as an introduction, mathcircle.org was actually started, we used Sam's Circle in a Box book, and we took all of the content from that book and put it on the website. So everything that's on the book is on there, but then we also made it into a wiki format so that if you have additional questions like that, you can add that in the comment section, you can add, as we have more and more program ideas, so that we wanted to make sure that it kept it as a livable document. In terms of asking questions like that, I think that was one of the goals that we were really hoping to have with more social networking, that you could post on the forums and sort of, we have a whole entire community full right here of people to start being more interactive on the website.
So are you saying that it is available?
This is presently a wiki. We were trying to use this wiki in this thing. I think the comment sections need to be turned on. I guess Brandy was pointing out that you have to be logged in. This is from Tatiana's section here, and Tatiana added a comment because she didn't quite see how to do the wiki. When you log in, you click edit, and you can say fix the security issues with the computer, but
it is editable both in Word and then also it does take tech. So for those of you,
He's writing something, as you said.
Yeah, you can write math formulas in it in tech. If it's missing features that you'd like to have, let us know. We can add them to it.
We have the feature request for embedding videos, so go back to the parody page.
Oh, go back to parody. So we've got that there. All right. So.
Ask
So-
and you shall receive.
Also, not only are we going to put all the materials up from all of the Circle on the Road workshops, we have a Math Circle grant program where if you're starting a Math Circle, you can apply to us and we can give you money, maybe around $2,000 to get going. And then, well, if you have that and you want to get money again, well, the next round to get money, it'll be a little harder. You'll have to submit at least one lesson plan and a suggestion of how you might start earning your own money. But if, we have 40 math circles that we're funding and 20 of them are in the second year, that's 20 new lesson plans a year, plus 13 at Circle on the Road. Pretty soon we're going to start building this up and you'll have new stuff, and if you just add them just for grins. So we want to do playing with parody, and did you stick it on the wiki or on the lesson plan page? So is this where you've embedded it?
Refresh maybe,
I
might be
I don't know.
Refresh.
Was it on the lesson plans page?
Refresh the page.
And the lesson plans page.
I didn't realize there were two different ones.
All right, so playing with parody here. So we can embed it in both. And there it is. So let us know what you want, and between the three of us, we'll try to get it up here. And if what we want is we want you to use it. So, Amanda, go ahead.
There are several people who want to announce us for lunch, so. Is it time?
I think so.
First of all, Tatiana asked me to remind everybody that there is a Sigma on circles. The MAA has special interest groups, a variety of them, and one of them is Sigma on circles for students and teachers. And what does it cost to join if you're an MAA member?
$12.
And then $20. $12, right. So if you're already an MAA member and you would be willing to help us out by paying the extra little $12 for the Sigma, it would really help. It allows us to hold, we'll have a session at MathFest with sample circles. This will be in Lexington, Kentucky this year. Sample circles, contributed paper session. We're working on a poster session for the joint meetings in Boston in January. So it'll just enables us to have
sessions on circles at both annual meetings. So if you're able to do that, and you want more details, talk to Tatiana. Send them at you. Okay. Or Jim. Send them at you too. Yeah, Phil.
At the joint math meeting in January, we're hoping to try a new kind of poster session. So we'll have a poster up, but a table in front of the poster with some kind of activity. So if you want to describe your circle on the poster, but then provide some kind of activity for people to do, we're hoping for a 2-hour session, and maybe have an activity that lasts 15 minutes or a half hour, and people can circulate and try out different activities. So look for that at the MAA site for joint math meetings, and sign up for giving an activity.
Other events of interest, Bob and Ellen Kaplan, who founded one of the earlier math circles, are coming to Notre Dame. I'm helping to co-organize that one. We have Math Circle Institute. It's the week of July 11th. We have teachers and mathematicians coming from around the country, and this is our 4th year doing that. It's just more about, we actually have kids come in the afternoon, and you try out your ideas on real life kids ages 5 through 18. Other events that are happening yes?
Well, Pat and her Teacher's Circle are alumnus of our summer program on how to start a Teacher's Circle that we run in Palo Alto and in Washington, D.C. each summer. And you can find more about that on the American Institute of Math website, or I bet Tatiana has some information in her pockets if you ask her.
Also, if you have events like this that are upcoming, you're more than welcome to add them as upcoming events on the mathcircles.org website, or if you email me, I will add them. If you just email me the flyer, I will add them up there as well, so that's a good place to go and look for the listing. I also try to get a newsletter done out and put out in January and in August, usually right before the joint math meetings and right before math.
Are there any other events that people want to make other people aware of for Math Circle community?
The New York Math Circle is having a teacher's math circle the last week of July. It's our 3rd summer of a math teacher circle, and it'll be up at Bard College in the Hudson Valley.
Yes, please.
Not an event, but people know of the extra circles, like email and stuff. No. Does anyone know that?
I don't know what you said.
There's
There's a circle of circles, like email listserv that I think maybe Dana Paquin, who runs the Stanford Math Circle, started up. Which
It's
is
on Yahoo.
David
Yeah.
Cordero is also working on it.
Yeah.
It's David in
Okay, I don't know who started it, but anyway, that's, people, like any listserv, people ask questions and give answers to problems like, what time, how not circle, or,
Yeah, no, but that was the one I was thinking of that doesn't, if everybody joins it, that would be great.
I-
Thank you.
This is a good time to
Yeah,
announce.
Circle of Circles, a Yahoo group.
And I'll make
Started
another
by David
comment that
Cordero.
I've had at this discussion with David and Dana is we've got a forum on the NAMC page. We asked why isn't anybody using it, and we discovered that the reason is that you can just hit reply in your email and reply to the forum without logging in to the Yahoo one, and you can't do that on the NAMC one. And David said we have a small enough number of users that if we add that feature to this web page, then we might just move the Circle of Circles over to the NAMC so that it'll be attached to the comments, the wikis, the lesson plans, the problem base, the problem sets. That'll happen in our next funding cycle, and so we hope that by next Circle of Circles, next Circle on the Road, we'll wrap Circle of Circles into the NAMC page so that it's all integrated together.